right, so last, if you can open your books, make sure you're on page 89.
Yes.
And then let's read our I can statement for our lesson 3-3.
I can use a raise and multiply.
Perfect, so we're going to be able to use arrays and partial products to multiply. So before we jump into our solve and share, I just want to go over something so you guys can have it in your head. We're going to be talking about rows and columns. Repeat.
We're going to be columns.
Okay, so rows go from left to right. Think of like a rowboat. Does a rowboat go up and down into the sky and under the water, or does it go left to right across the water?
Left across water.
Row goes left to right, and eventually, as you get older, that will be known as the x-axis. Okay, row is on the x-axis. Repeat.
Row on the x-axis.
And then columns go up and down. Like a column will hold up a house. The Colosseum has columns. And if you write out the word column, there is a column. So columns go up and down. Okay? Thank you, Carson, for letting me know that you are connecting what I'm saying. So, and that would later be known as the y-axis. Repeat, column. Okay, so our solve and share. A music room has chairs arranged in rows. There are 6 rows. Each row has 18 chairs. How many chairs are in the music room? Go ahead and solve the problem. Any way you think will help you. And there's an array here with a bunch of boxes. I'll give you a couple of minutes. And I'll pick a couple of you guys to come up and show how you solved it. Remember, rows are left to right. And remember, there's no right answer. We're just looking at how your brain thinks. So don't erase what you put down. I'm coming around to see if I like how your brain thinks to show it up for the whole class. All right, some of you guys have shown that you're done. Marika, would you mind coming up and showing us how you solved the problem? I think I did it too. Yeah. All right, okay, so Marika's gonna show us how he solved the problem.
So what I did is I did 8 times 6 right here. I did 8 times 6 first, 18. I did 8 times 6 first to get 48. Put the 4 up here. And then I did 6 times 4 to get 6. Then I added 4 and I got 12.
Okay.
Okay.
You made a mistake. I never always fix it. You wanna fix your mistake? Okay, so where did you get the numbers 18 and the number 6?
I got the number 18 the solving shift.
So it's 18 what?
Chairs.
So we have 18 chairs and you multiplied it by 6 and it was 6 what? 6 what? 6 rows. Okay. So you multiplied it and you got, what was your answer?
I got 106.
And then what did you do under that? Because I see that you have some more numbers.
So what I did is I estimated it. I did 6 times 18. I estimated 18 to 40.
Okay.
And then I did 6 times 40 to get 140.
So you used your estimation to kind of double check your answer? And did you think it was reasonable? 120 to 108?
When I found out that my answer was wrong,
I think it's pretty reasonable. You're only off by like 12. It's not like you're off by 200. I think it's pretty reasonable. Good job. Thank you. Oh. And then, who else is done? Jacob? Ikeda? You want to come show me how you did yours? Oh, bring your notebook so we can see your work. Bless you. All right, so
So what I did with it is I did, because there were 6 rows with 18 in them, I did 18 times 6.
okay,
So I wrote that and it was 108.
okay.
And if, wait, I did,
What do you mean? No, don't erase it. What does it say?
with,
Oh, you're answering the next question. Okay, so you had 18 and you said there was 6 rows.
yes,
So you multiplied or did you add?
I added.
Okay, so you added 18 how many times?
I multiplied.
You multiplied?
Yes.
That looks like addition to me. Is that addition?
Yeah.
Yeah. So you added 18 6 times and you got 108? Awesome. And I see that you used the array to show the 6 rows and then the 18 chairs in each row. Perfect. Good job. And then let's do one more. Let's see. Isabella, you want to come show me? Yep. All right, what did you do?
So I first I colored in the 6 right here.
Ooh, let's start, where's the problem? What did you do on the problem?
Problem?
Yeah.
I said 6 rows and 18.
So you highlighted the 2 things that you needed to do?
Yeah.
Okay,
Then I colored in 6 rows right here.
okay,
And I colored in 18.
okay. And then what did you do?
So down here,
Mhm.
I did 16 times 8, but I rounded it to 20.
Okay.
And I got 120.
Okay.
And I did the 8 plus 18.
Mhm.
I got 122.
Okay. And did you find that to be reasonable?
Yeah.
Okay. I think your math on the 18 is off by a little bit. I think our other friends got 108. But you're pretty close. And 120 was close to your answer. Perfect. Thank you. And thank you for showing us your graph. All right, guys. So there's different ways to solve the problem. Let me look. So like Isabella did 1, 2, 3, 4, 5, 6, and she went across 18. And this was all of the chairs. And then like Marika showed us, some people added. Marika did multiplication. I think I'm gonna do multiplication like Marika did. So it was 18 rows, 18 chairs times 6 rows. And just like we regroup in addition, we regroup in multiplication. So 8 times 6 is 48. And if you don't know, check your name tags. If you don't know it. Yes, Ethan.
Do we have to write it exactly like you?
No, I'm just writing it down. So 48, and I would carry my 4 to the tens. And then 6 times 1 was 6, and you add the 4, and it would be 100. So there was 108 chairs. Now it asks us, would the answer be different if there were 18 rows with 6 chairs? Aria, what do you think? Do you think it would be different?
No, I don't think it would be different because commanded it properly. So they just flip-flop for numbers.
Yeah,
And it's just not
it would be the same. Because 18 times 6 is 108. Whether it's 18 chairs and 6 rows, or if it's 18 rows times 6 chairs, it's still 108. Because the numbers that the question is providing us is the same. It's just instead of it being 18 chairs, it's 18 rows. And instead of it being 6 rows, it's 6 chairs. So it's the same. Yes, Hashem?
Can I solve your sentence? I've been working hard on it.
Sure, you can share your sentence.
No, the answer wouldn't be different because the commutative property of multiplication states that even if the first two numbers of a multiplication are swapped, the sum would be the same.
Yeah. So for multiplication, it wouldn't be a sum. It would be the product. The product. But yeah, you're correct. All right, guys. Now, if you guys can come down to the carpet, I'm gonna play that video for you for that next problem.
It's held up there, the syllabus.
Camilla, please stop.
I apologize, Ms. Chacon-Kreysa, I have it right here, it's not sliding over.
No, it has to be continuous.
Close up, so then let it roll, it wasn't applicable, so I closed it, it sounds. Yeah, because I was like, well, you just flip this around and put it here.
Okay, so while we are waiting for the computer to start again, our problem was 18 times 6, right? We, some of you decided to add 18 6 times, which isn't wrong, but we're gonna be working on our multiplication. So we were, separating our numbers. Remember, we were elongating it? Like 254 was like 200 plus 50 plus 4.
Yeah.
Okay, so if it's 18 times 6, how would you separate 18? Hashem? 10 and 8. So do you think multiplying 6 times 8 and 6 times 10 would be a little bit easier for you than multiplying 6 times 18?
Yes. Yeah.
Yeah, so that's pretty much what you do when you are doing multiplication. You're working by place value.
But wouldn't 6 times 10 equal 60?
Yes, it would. So what you're doing is just the same way that you start in the ones place and then move to the tens place and then move to the hundreds in addition, you would start in the ones place for multiplication. So it's possible that you may have to regroup in the ones and carry something over to the tens. So 8 times 6 was 48. So what would there's not 48 ones. How many ones are there in 48? 48. There's 40 tens and 8 ones.
480.
No, sweetheart. There's 4 tens, so there's 40, and then 8 ones.
48.
Correct, 48. So if you're multiplying 6 times 8, it's 48, so you would carry the 4 to the tens, and you would just write 8. So like you said, 6 times 10 was 60, and then you would add 4, so 6 plus 4 is?
6 plus 4.
4 equals 10.
Yes. I need you guys to disperse. You can't see where this grade from where you're sitting.
How can you use an array and partial products to multiply? The windows of a building on International Drive are in an array. There are 5 rows with 13 windows in each row. How many windows are in this array? How many windows are in one row?
Select your answer.
So how many windows are there in that first row?
13.
Does row go left to right or
No.
up and down?
Up and down.
Okay. Class.
Yes.
A rowboat goes across the water. So does a row go left to right or up and down?
Right.
So how many windows are there in the first row?
13.
Perfect.
An array is an arrangement of objects in equal rows. There are 13 windows per row. There are 5 rows. Find 5 times 13. 5 times 13 is about 5 times 10 equals 50. There are 5 rows with 1 10 in each row. 5 times 10 equals 50. There are 5 rows with 3 ones in each row. 5 times 3 equals 15. 50 plus 15 equals 65. The numbers 15 and 50 are called partial products. 65 is the product. You can use place value to break factors apart and the distributive property to find partial products. Breaking the equation by place value shows multiplying the 1-digit number by ones and then tens. 5 times 3 ones equals 15. 5 times 1 10 equals 50. Add the partial products. 13 times 5 equals 65. There are 65 windows in the building. The product 65 is close to the estimate of 50. The answer is reasonable.
All right, guys, that was it.
That was kind of good.
Can you switch it to the other? You guys guys can go back to your desk.
Say hi in the chat. I actually see you. Hi. Zoe, you know this is probably on your grade. Oh, shoot.
Okay, so that's something, Zoe, we're submitting to the state of California. And when you do that, how do you do that? Oh. And now can we record the entire lesson?
Okay. So in the next page, this is the problem that we were just doing, or that the video just showed us. So it's asking us, how are the partial products represented in the place value blocks? When you look at this top square, how do you think they are represented? The partial cancels. Yes, Hashem.
So basically, it's showed by cubes, like the cubes, and since each row has 13, they represented the 5 rows of windows in the buildings and put 13 in each to represent how many windows are in each row.
Yeah. So they separated each row, and they have it separated by groups of 10s and then with groups of 1s. So it shows us the partial products. These are 10s and that these are 1s. So it breaks the factors up into groups of 10s and 1s. Thank you, Sarah, for letting me know that you're done. Alright guys, so the next page has another example. So it's asking us to find 2 times 126. So if you estimate, just so that we can check our actual answer, they estimated 2 times 126 to 2 times 100. Would you agree that is a good number to round 126? I do too. And then the array shows 2 rows, 100 in each. That's 100 and that's 100. So there's 200. There is 2 rows that have 10 in each. So that's 2 times 20. And that was 40. And then it has 2 rows that have 6 ones in each. There's 6 here and 6 here. So there's 6 in each row. So there's 12 singles. So then when you put it all together, this one does it a little funky. I don't like this one. They kind of do it backwards. On the previous page, you see that they did the 1s first and then the 10s because we work from right to left. So this one did it left to right. So it's a little funky, so we're gonna do it again, but doing it from right to left. So first, what is the first column on our right in 126? Hundreds, 10s, or 1s? Ones. So let's highlight our 1s and then circle what our 1s were. So 6 times 2 was 12. And then our 2 in 126, is that hundreds, tens, or ones? So then we'll circle our tens, our group of tens. And that was 40. So I'll highlight the answers with it as well. And then our last one, the 1 in 126, is that hundreds, tens, or ones?
Hundreds.
Yes, hundreds. So I'm gonna highlight the 1 in hundreds, circle the group of hundreds, and then 2 times 1 is 200, so I will highlight my 200 also in that same color. And then you just add it all up. So 2 plus 0 is
2.
4 plus 1,
5.
and then there's nothing else that you would add the 2 to, so you would just bring that down. So our answer is 252. Is that close to the estimate that the book gave us of 200?
Yes.
So an array can show multiplication by showing us the number of rows and the number in each row. So it'll show the number of rows and the number in each row. And it's really important to look at each row, so I'm gonna highlight the word each, because you can't just count it in one row. You'll have to count each one in each row. Alright, so for number 2 and 3, we're just going to practice a multiplication first. So to set up 2 times 24, we put 24, would that be on the top or the bottom?
Bottom.
It would be on top. And 2 would be on the bottom. The reason why is because you can put that single number into both of the bigger numbers. So the bigger number goes on top for multiplication. So let's multiply the ones place. 2 times 4 is 8. And is it 2 times 2 or is it 2 times 20?
2 times 20.
Because it's in the tens place, so it's letting us know that there are 2 tens. So it'd be 40. So I forgot to highlight. So highlight the tens place, highlight the answer for multiplication in the tens place, and then you add it. 40 plus 8 is?
40 plus 8 equals 48.
Okay. And then number 3. 218 on top or 3 on top?
218 on top.
Thank you. Times 3. So our ones place is what number?
8.
8 times 3 is?
8 times
3 equals 24.
24. Our tens place is what number?
3.
Our tens place is what number?
1.
3 times 1 is? Oh, I'm sorry. Is it 3 times 1 or is it 3 times 10?
3 times 10.
So 3 times 10 is?
3 times 10 equals 30.
And then what is our hundreds place?
The 100. No, 400.
So is it 3 times 2 or is it 3 times 200?
300.
And what is 3 times 200?
3 times 200 equals 600.
3 times 200 equals 600. And then you will just add those up. So 4 plus 0 is what, class?
4. 4 plus 0 equals 4.
2 plus 3 plus 0.
2 plus 3 plus 0 equals 5.
And 6 plus nothing else equals?
6 plus nothing else equals 6.
Okay. Number 4, yes, Adria. Sure. Can you write them? Great. Yes, Kenda?